All right, let's now talk about the stuff. Your written test number 2 result, I'm gonna release it by early Monday. So you can expect to receive an e-class announcement from me early Monday. And for your lab number 4, please don't forget, it will be due tomorrow noon. All right, make sure you don't miss the submission deadline to claim your credits. And for your last final lab, number 5, it also has to do with inheritance. It's also another interesting lab, which will also use inheritance, but it's a completely different problem to solve. You can also see the value of using inheritance. All right, anyway, so once you receive it, you can work on that. And your programming test number 3, that'll be the final test for the semester before the exam. It's going to be next Wednesday during your lab session, and I already released the guide talking about its coverage, but very briefly. It's mainly going to be about lab number 4. It's going to be a simplified version of lab number 4. What you can do is you can take advantage of the grading test and solution video. I already released them. All right, so I'll leave the option to you. If you still want to work on the lab number 4 on your own before the submission deadline, that's no problem. But if you want to maybe take an early look at the solution and study along with it, that's also no problem. All right, I'll leave the option to you, whichever that works better for your learning. And there will be another bonus opportunity from November 18th when they open up the online course evaluation. So that'll be the formal one. And that one there, similar criteria. So if the collective response rate reach like a high level, then we can, all of you guys can be rewarded some extra mark. But I'll reach out to you. So that'll be starting from Monday. Okay. Okay. Any question about the course? All right. If no, let's now continue with inheritance. Quick recap. All right. So last time we actually talked about the intuition of that dynamic binding, and we're going to talk more about dynamic types today. And you want to make sure you know how to fill out a table like this, especially how you can keep track of the dynamic type over here. All right, I'll leave the details to you. All right, you got to study for that for the exam. Okay. And then we talk about multi-level hierarchy. This will be one example. This will be another example. A very important exercise for you to do when you study for the exam is to really revisit design number 1, design number 2 without the inheritance versus design number 3 with the inheritance to compare them and contrast them. Right? That will be a very important exercise for you to do. I'll leave that to you. And we talk about ancestor, including the class and all the way to the top of the hierarchy. And also we talk about descendants, the other direction also includes the class itself and all the way down to the bottom. Right? We're going to use this more today when we define the rules, not just for variable assignments, and also for cast. So today, hopefully, we'll complete the story for the typecasting. Okay. All right, and then we talk about how to figure out, given a class, for example here, how you figure out its ancestor, expectation, and descendants, right? We did an exercise together, so please make sure you can do that as well. It's a very basic exercise. I'm going to assume you will know when you walk into the exam room. Okay, and then we'll talk about variable assignments. So for this one here, just an example, but I remember, yeah, so this one here, right? There's something I'm also going to summarize as a first thing today, but just remember, whenever you have some variable assignments over here, and also you got inheritance in the context, always remember to judge for compilation, you have to look at the static type for both variables over here. All you got to ask yourself is, can the static type over here fulfill the expectation of the static type over here on the left-hand side? If you can, then it compiles. If you cannot, it doesn't compile. As easy as that. Okay, I'm going to visualize that one more time for you. Okay. And we talk about just more example about expectation, right? The lower the class is in the hierarchy, the more expectation you can expect. If you compare, for example, static type students versus static type non-resident students, apparently this one here has more expectation. All right, that's another observation you have to keep in mind. All right, so that's basically it from Tuesday. Any question? All right, if no, let's now continue. And the first thing I would like to do is also to recap a little bit about substitution. So if you go to the slides, this is a slide you want to pay attention to when you study for the exam. Slide 44. It basically got 3 rules over there. I'm going to talk about each one of them one by one. A little bit dry, but when you visualize it, it's not too bad. So this is what you want to start with. Let's say we have some variable assignments, and then we have the left-hand side of static type A. Let's now try to show to you the diagram I have, and then we'll go over the rule one by one. Okay, this diagram, I'm going to use it pretty soon. And let's say we got some variable assignment here. We say object A is assigned to object B. What we know for sure is the static type for A is A. Sorry, the static type for OA is A over here. Right? You can see this. And I can mark it down right away. You can see for the left-hand side here, I see OA has the static type A. And I want to assign to it OB. And OB here, I simply put question mark. I leave it open for now. So what you got to understand is, according to the rules, what's the range of classes you can put as a static type for OB such that the variable assignment is going to compile. That's the problem we are solving. Right? So what we're going to ask ourselves, what can we put as question mark such that this one can compile? So that's the question we are asking. What can the static type of OB, which is question mark, be to make this substitution? Right? We talk about variable assignments. Another way to interpret that is by doing substitution. Substitution, compile. This is the first critical question we want to solve today. Right? Just remember that. Okay, make it a little bit thicker. There's one. That's a critical question. All right. And let's now go over the rule one by one. And the rule somehow can cover every possible class in the hierarchy. All right. We're going to do a concrete example in a moment. But conceptually, we want to make it clear. First of all, let me now put A into context. A is here. And remember, A is the static type for OA, the left-hand side. Now, where the static type B for OB is going to impact whether it's going to compile or not. Let's go over rule one by one. Rule number one. It will be safe, or it will be compilable to substitute by any variable whose static type is a descendant class of A, meaning that it can satisfy the expectation. All right, so what do I mean? So here, if you think about what can question mark be, it tells you that it can be any of the descendant classes, which can be this one here, all the way to the top of the hierarchy. These classes. Basically, all the classes along, we call the ancestor path. They are okay. You can assign. I beg your pardon, I said exactly the opposite. I do apologize. Let me say it again. You might be realizing, right? Okay. Descendant classes. I do apologize. That's a terrible mistake. When it compiles, that means it can be descendant classes, because we know the lower the class is in the hierarchy, the more expectation you can have. Of course, it can satisfy the expectation for A. So what I really meant to put is over here. A itself is okay, it's its own descendants, and every class underneath. These will be the classes you can put for question mark to make it compilable. Right? So these are the only classes. So these are the descendant classes. Descendant classes of A that can serve as the static type of OB, which is the right-hand side of the assignment. And you will still make it compilable. It will be safe. All right, this is the safe case. Rule number one. And rule number 2 and 3 tell you what will be unsafe. Unsafe intuitively simply tells you that if you substitute A by something that cannot fulfill its expectation, then it will be unsafe. Conceptually, there are 2 possibilities. Number 1, if you substitute A by itself, that's okay. But starting from A's parents over here, we know that the expectation is going to be either equal or less, but in general less. So this parent class cannot fulfill the expectation for A. So this one will be unsafe. Similarly, its parents will also be unsafe and all the way to the top. So all the ancestors cannot be used on the right-hand side for substituting A because the expectation cannot fulfill A. That's number one, right? Unsafe case number one. Unsafe case number two. There are certain classes, for example, let's say there is a class over here, like a sibling. Sibling is neither an ancestor nor a descendant. So they are also unsafe because remember we said before, for a sibling, their expectation has nothing to do with their sibling classes. So you can also not substitute them for the static type. All right, let's take a look at bullet point one by one. Second rule, it will be unsafe to really substitute, notice what I said here, the ancestor classes of A's parents. So A is okay, but A's parents onwards all the way to the top of the hierarchy is unsafe. All right, so let's now distinguish between them. So unsafe case number one, basically starting from A's parents all the way to the top of the hierarchy, right? That's unsafe, okay? So these are ancestor of A's parent with less expectation, so they cannot fulfill. All right, so this will be unsafe. Okay, that's unsafe case number one. All right, the final case, which will be, if you look at the slides, will be bullet point number 3. It will be also unsafe to substitute by any type that's neither ancestor nor descendant. They basically got incompatible expectation. It's not really about more or less, just incompatible, right? All right, so how do we annotate them? So at this level here, this is incompatible over here. This one here is more like your uncle, aunt, right? Your parents' sibling, basically. All right, this one here and this one's here. So these are all uncompatible. So these are the neither ancestor nor descendants with incompatible. Expectation. So they will also be unsafe. So this is a very complete and general rule about what you can do for variable assignment. All right, any question? So when you study for the exam, make sure you kind of go over the bullet points one by one and try to see the correspondence of either this part over here or this part over here or this part over here, right? You want to be very sure about which part should be which. Yes? You cannot assign to the sibling because sibling will be here, right? Yeah, sibling will be classes or like a sibling or cousins in general, right? You can think about all the classes in this branch over here. They kind of share the same ancestor as with you, but they don't have really compatible. For example, if this is resident students, this will be non-resident students. They simply got incompatible. One has premium rate, the other one has discount rate. So you cannot substitute. All right, any question? So the rest will be, we want to do more example. All right, so that's the general rule. Let's now go over some example here. All right, I'll try to solve maybe one of them, and then the rest, the other one will be exercise for you. But all the solution can be found on the slides. Let's now take a look at this one here. Should it compile or not, right? Only this one here. The way to judge is by looking at, number one, you can see for SP1, what is its static type? iOS. So what you do is, if you have some sketch paper, you can definitely put iOS over here. So this is the static type of SP1. On the other hand, we got another one here, SP2, the right-hand side. SP2 was declared to be iPhone SE, which can be located over here. So this will be the static type of sp2. Now, should this be compilable? It should be, because this can satisfy this for expectation. It's a descending class. That's basically bullet point number one. All right, this because this is one of the descending classes, which is like this case. All right. All right, so that one should be a check. And this one here, exercise for you. Any question? Go ahead. The reverse will not work. So when we talk about expectation, we talk about ongoing basis, because we know that for, let's say, iPhone SE, at the moment, yes, there's no additional attributes or methods. But if you talk about ongoing basis for the class, you have the freedom to add new attributes or methods if you wish. So we want to account for that possibility in the future. So we always say the subclass always has more expectation than its parents. We always say that. Even though at the moment, maybe you don't have new attributes or methods in the subclass just yet, but it's very likely you will have at the future. Okay? That wouldn't work. For example, if you swap this, you say sp2 assigned to sp1. Basically, what you're doing is you're substituting sp2, which is iPhone SE, by iOS. That would be basically this case ancestor. So that wouldn't work. Okay? Question? Yeah, of course. Sure. So you want to assign what to what? Say it again. Okay, this will be the left-hand side. Okay. Right-hand side what? Okay, this one here, right? Okay. If you want to, that's a good question here. If you want to assign this one here to this one here, what do you think? No, it's not going to work. Because this will be case number 3. Because if you try to assign this guy here to this guy here, this one has to be its descendants. But this is neither descendants nor ancestor for this one here. That's exactly this case over here, sibling. Watch out. Okay? All right, another example. So what about this one here? That's basically what Jennifer just asked. So let's say if I say now sp1, again, let's now annotate. sp1 has the static type iOS over here. And we also got sp2, which is smartphone, which will be over here. And when we consider this assignments over here, I'm basically asking for sp2, is smartphone going to satisfy the expectation for iOS? Not really. It's ancestor. How can it satisfy? All right? That's basically this case over here. Okay? So this one, no. Neither, oh, so this one just ancestor case. You can think about, I'll just write this one down. Cannot satisfy the expectation of iOS. That's why it wouldn't compile. All right, final example. What about we got sp1, sp2? That'll be case number 3. sp1 is iOS. And then sp2 will be Huawei IP50, which will be here. All right, so this one here, we're basically asking the following. sp2, which is over here, right? sp1 is here. Can this satisfy the expectation of this? It will only satisfy it if this was a descendant of that, but that's not the case. It's neither ancestor nor descendants. No. All right? No. Neither, sorry, I'll write a little better. Neither ancestor nor descendants. So which would be this case over here. They got incompatible expectation. right? Hopefully this can reinforce what we learned from Tuesday, and I try to teach that from a slightly different angle, just a little bit more general, more precise. Okay, hopefully that will help. Okay, very good. That's good. Let's now go over a little bit slides and see where we are. So we basically talk about the rule of substitution, and we talk about dynamic type. Okay, let's polish a little bit about the notion for dynamic type. So dynamic type is basically the type of object that's being pointed to by some reference variable at the runtime, the title of the box. And then the dynamic type may change whenever you like. Okay, and there are two ways to change the dynamic type. We're going to see two possible ways. All right, first of all, let's now talk about visualization. And this visualization might help when we talk about typecasting very soon. This one here, you can read the slides, but I will just show to you what I really meant over there. So when you declare some objects over here, okay, let's say I declare S to be students. And student here is the static type. You know that right away. So the student over here is the static type. On the other hand, you try to say S should now be reassigned to some new objects. And this is something that we have been doing about how you can trace the dynamic type. We're going to do the same thing. Okay? So this one tells you that after executing the reassignments, this will be the dynamic type. All right? Now, how do you visualize this situation? We know pretty well S points to dynamic objects, resident students. That one is pretty good. However, sometimes it might help if we also put besides the variable here to say students, just to remind you it's a static type. And this will be very helpful when we talk about casting. All right, so when I trace objects like this, when I put also the static type besides the reference variable, shouldn't be too surprised. You can choose when to do it and when not to do it. When it can help you trace your code, you definitely may want to put the static type over here, especially when you want to trace something about casting. All right, that's just about visualization. Just remember to put a static type besides a reference variable when you find a need. And then after this, I'm going to talk about there are two possible ways to change your dynamic type. Approach number one, you basically just trace the new expression. And new expression over here, right? Another way, which I will show to you, is just by reassigning the variables. We'll get there. Okay, I'll talk about one by one. Approach number one. Okay. So let's say here we got Jin and we got students. Okay, static type. So I'm going to put the students over here as a static type. And the question that can be easily derived from what we just talked about, the variable of substitution. What can be the potential dynamic type I can put over here on the right-hand side? Any class that's the descendants of students. Because it's guaranteed if you put a descendant class over here of students at a runtime, it can satisfy the expectation. So if you look at the slides, that's a rule about if you put some new expression here, creating a new dynamic type for this variable here, when can it compile? It will compile if this class over here is a descendant class of that, because the descendants can satisfy the expectation, right? So how do we visualize this? You can think about dynamic type number one. Resident students over here is a descendant class over here. So this is good, all right? You can fulfill. And after this line over here, which we traced earlier, dynamic type of Jin has just become resident students. All right. And then we try to do another reassignments. And how can we judge whether this will compile or not? You want to ask yourself again, can this new dynamic type over here, which is here, can it fulfill the static type of Jin, which is student here? It can. Positive. Because non-resident students is a descendants of students. It can fulfill the expectation, right? It's all about expectation. So think about non-resident students here will be the new dynamic type, which will be here. And this one here is guaranteed to work because this one here, for example, can fulfill. How about this? I'll put in general. in a moment. But after this line here, the dynamic type of Jin is going to change to non-resident students. But the important thing here, I want to write it down explicitly, is for this one here and this one here, both of them, both classes can fulfill the expectation of Jim's static type, which is students, right? That's important. It's also just like a substitution that we are talking about. Right, that's approach number one about how you can change the dynamic type. All right, how about this one here? Is this going to work? I declare Jeremy to be of static type resident students. And then I'm asking, can I assign a new dynamic object to it of type students? Can I or can I not? All right. Of course, this is something you want to be very familiar with. All right. The answer is you cannot, because students is not a descendant class of resident students, so you cannot fulfill in general. All right. If that's what you're thinking, that's great. Okay, this one here is not going to work. Not compilable. So when I put a cross, I meant it's not compilable. And of course, it will be very ideal if you can also try these out in Eclipse as well, right? Because the students at an exam, I will expect complete answer to complete two parts. Number one, students is not a descendants of Jeremy's static type, which is students. That's part one. Number two, students cannot fulfill the expectation of Jeremy's static type. Right, both parts are important, right? So you gotta make sure you practice, about such stuff. All right, 1 and 2. All right, good. Next one. All right, how about this one here? How about we'll just agree on the answer, and then the detailed rationale, it will be up to you, right? You gotta write it down, just like how I wrote it down for the previous example. Should this compile? My phone, static type, Android. Here, Huawei, which will be here. Indeed, a descendant class, right? So that one should compile. After this line here, I should have the dynamic type changed to Huawei. All right? And then I try to do a new reassignment here. Now, similar question. Can Galaxy S21 fulfill the expectation of Android, which is its static type? Can it? Of course, it's a descending class, right? So both of them should compile, both of them. And I'll leave this page clean for you so you can practice that, right? Both of them compile. And that's also explained on the slides. All right. One more. How about this one here? iOS over here assigned to Huawei. No. Right? It's neither ancestor nor descendants, so it's not going to work. How about reassign iOS to Galaxy S21? Also not good, right? Neither ancestor nor descendants. All right, good. Very nice. And when you change the dynamic type, it tells you that dynamic binding. Oh, just before. Okay, question first. Which one? This one here? This one here? You mean here? Sure. If I modify this one to be Huawei, it will compile actually. The second line. Okay, let's talk about line by line. Okay, the first line here, Huawei P50 Pro can satisfy Huawei. That one's good. But this one here, Galaxy S21, is neither ancestor nor descendant, so it wouldn't compile. Okay, good. Extra one. But we're following the same principle, right? You can see I can generate millions of questions from here. But once you understand the principle, it should be straightforward, right? Okay, so good question. I like that. Let's see here. Okay, this will be exercise for you. Give it a try. Okay, this one here as well. Give it a try. All right, so this one here is really about dynamic binding. So this one tells you when you actually go gym is assigned to RS versus gym is assigned to NRS. Both of them will compile. And the thing is, whenever you try to call a method here, the version of the method depends on the dynamic type for the context objects, right? That's something we said on Tuesday, right? You want to really refer to it. So this one here is more like a repetition. So what I will put is some question here for you when you study, right? So when you call this method here, what's the dynamic type? Once you figure out the dynamic type, it's going to actually call the corresponding version. And then when you try to make the same method call over here, what's the dynamic type as well? All right. And this one here we cover already. And this one over here, okay, RS assigned to gym shouldn't compile, right? Because RS, resident students, here, can it be substituted by gym, that's students? No, cannot be. Opposite direction, right? So this will not even compile. Okay, so this is not even going to compile, right? Right? That's something we also said earlier. So when I ask you about what's going to be the version that's going to be called over here, it's not even the right question because it's not even compiled. There's no runtime. Okay. All right, so let's now define polymorphism and dynamic binding, and we are ready for that. Okay. And let me go over the slide. So we are done with this, and we are done with that. Okay, polymorphism and dynamic binding, they kind of go side by hand in hand, so they're kind of related. Okay. So poly simply means multi, and morphism simply means shape. Okay. So polymorphism really means a reference variable may have multiple possible dynamic types at the runtime, as long as the dynamic type is actually a descendant class of it's a static type, right? So multiple shapes. So for example, let's say this. If I declare my variable to be of static type students, dynamically, what can be the dynamic type for students? This variable. It can be any of the descendant classes of that particular variable. So that's polymorphism. All right. Let me just go back here and then give you a little bit highlights here. Polymorphism tells you here for gym that is declared to be of static type students. We know that at runtime, dynamic type of gym can be any of the descendants of gym's static type, right? That's polymorphism. You got multiple possibilities for dynamic type. Any of the descendants, that's polymorphism. And the consequence of polymorphism tells you that because I know dynamically gym can either be resident students or non-resident students. I got two possible versions for me to choose for get tuition. Which one should be chosen? Corresponding to what the current dynamic type is for gym. For example, at this point over here, gym's dynamic type is actually resident students. So it's going to call the resident student version. At this point here, gym dynamic type is non-resident students. So it's going to call this version instead. So polymorphism tells you for a reference variable, it has multiple possible dynamic types at the runtime. Dynamic binding is a consequence to say at the runtime, which version of the method should be called. It depends on the current dynamic type. All right, these two things go side by side. And if you look at this one here very quickly, okay, this one is like a new one. Now, if you look at SP1, smartphone number 1, and also SP1 over here, you are basically calling the same method, surf web, surf web. But which version is it going to call? Is it going to call the version with Safari or the version with Firefox? Right? When we talk about SP1 over here, it's iPhone 13 Pro. Right? So that one there is going to call, dynamic type is iPhone 13 Pro. It's going to call the iPhone 13 Pro version, okay, over here. On the other hand, when we talk about SP1 over here, that one SP1 has been reassigned to SP2, which has the dynamic type Galaxy S21 over here. Right, it's been reassigned. So the dynamic type has become Galaxy S21. So this one here will be Safari. And this one here will be Firefox. Right, so it's different. It really depends on the dynamic type you're going to trace. All right, any question here? Well, I can see we really try to build up, the understanding. So I don't really need to do that detailed tracing anymore because it's more efficient to see how things can be done. The only thing I want you to make sure you really understand is when I say SP1 is reassigned to SP2, number one, you got to make sure you understand why it compiles, which we said in the beginning. Number two, how does the dynamic type of SP1 change to that of SP2? You got to do the tracing, and you will see that SP1 is going to point to some Galaxy S21 objects afterwards. So that's why its dynamic type also changed. Okay, question? Good. Okay. All right. Guys, final call. That's about it I want to say before the typecasting, which is more important to understand. All right, let's now move on. Let's now talk about typecasting. So this will complete the story that I promised when we talked about typecasting many weeks ago, right? What I will do is, let me show you. So we have done with polymorphism and dynamic binding. When you go over the slides, we just got more example for you to trace, all right? But everything has been talked about. All right, that's good. That's being spoken about. And this is the one we just talked about on the page. And I think that this example here might be new, but you can look at that too, right? Just an extra example. Okay. All right, typecasting. Let's now talk about it. Let's use our familiar example, student, resident student, non-resident students. Now let's look at 3 lines of code. Number 1, we have Jin over here declared to be students, and this dynamic type is good because resident students can fulfill students' expectation. So that one's good. Now, can I write this line here? Can I or can I not? Line number 2. Does it compile? Anybody? Don't forget, Jim here has the static type students. So you want to ask yourself, can students fulfill the expectation of resident students? No, it cannot. Does not compile. All right. However, I have some challenge for the compiler. If you look at the visualization, let's now look at that. From line number 1, I have Jin declared to be a student. After this variable assignment, Jim is really pointing to some resident students object here. Resident students. So right here is a dynamic type. My intention is, given that this is really a resident students object, I just want to make sure I can assign RS, which was declared to be a resident student's static type. I want to assign that to here. It makes total sense because what I'm trying to do is something that's declared to be a resident student, I want to let it point to resident students. But currently I cannot do it because the rule tells you you cannot substitute students by resident students. You cannot. All right. So I said it the opposite. Current rule tells you you cannot substitute resident students by students. That's what I meant to say. Okay? Isn't compilers too unflexible? Not flexible at all. So now here's my challenge for you. The compiler doesn't seem to be very smart in knowing that at the moment, Jim is indeed pointing to some resident student objects. So they should really extend their rule to allow RS declared to be a resident student to really point to an object with a compatible dynamic type. Right? Here's my challenge for you. I call this the A+ challenge. I'm going to describe a problem for you. If by the end of the term, any one of you can write a program which will do this, I'll give you A+ right away. Right away. No question about it. And don't even need to write the exam. All right? Here's the problem. Your program basically will take two inputs. This is your program you're going to write. You can write in Python, you can write it in Java, C++, whatever language you like. It will take input number one, some Java class, which can look like something like this. Maybe you have a main method here. I declare S, and then I do something valid, and then in the last line, I try to reassign S to be new resident students. So from this program over here, I know that the very last dynamic type of S over here is resident students. Agree? Your program, if can somehow tell me, given a program like this, and give like a variable name, like a S, you simply tell me what the last dynamic type is for S. In this case, it'll be resident students. If your program can do this and show it to me, A+ for the course. Anybody think that's possible? Here's the thing. If you could do this one here, solve this problem here, what you deserve is not A+. You deserve a Nobel Prize. Because this is known to be something that's not possible. All right? Most of you are in the engineering major, so you wouldn't get a chance to study 2001, the theory of computation. But for your knowledge here, what I'm describing here to keep track of dynamic type is some problem called undecidable problem. It's the limitation of a computer. You might be thinking that computer is so powerful, it can solve so many problems. It's not true. There are so many, way more problems which cannot be solved by computer. What I just described over here is just one of them. All right? So guys, please don't try. Don't waste your time. It's not even possible. All right? Inferring dynamic type over here is known to be impossible. So that's why Eclipse compiler or any programming language compiler does not implement it. It's just not possible, right? Undecidable. All right. All right. Let's not worry about proving it. I'm telling you the fact. All right. Knowing that keeping track of the dynamic type is not possible. So that's why when we go back to the previous page, when I thought the compiler is not flexible enough to know that at the moment, RS is really pointing to resident students. Oh, sorry, Jim is really pointing to RS. It's just not possible to be kept track in general. All right, so that's why the compiler didn't do it. So the workaround will be, you as a programmer, you should really try to supply some type to be cast that can tell the compiler that me as a programmer, I'll take the responsibility. Do the cast for me. If you can do it, just continue with the coding and make it compile. That's about typecasting. All right? That's kind of the missing information from before, right? So this page here is really for your information to know that keeping track of dynamic type in general is just not possible. So that's why no compiler would do that. So this gives us the power to do something called typecasting. All right? Let's now talk about typecasting. And typecasting, the intuitive idea is, now I have some static type students pointing to resident students. If I know for sure that dynamic type is a resident student, for me as a human, I'm smarter than a compiler. I know at this point the dynamic type should be resident students. What I can do instead is to create some alias over here. And then that alias has a different static type, RS. Once I got this alias over here, I can assign this alias to, for example, here. That will fulfill the expectation. I'm trying to create an intermediate alias so that I can fulfill the substitution rule. That's basically what I'm doing here. All right, let's now talk about how the typecasting really can be understood. All right. So what we have is we got Jim here, and has a static type students, and dynamic type is resident student. That's from the previous example, right? You like this, that tells you you're creating an alias. So this expression over here tells you that you're creating an alias over here without a name. And that alias has the static type resident students. That's the right-hand side. Once I have got that, now compiler will be happy because I'm basically asking compiler rather than assigning just Jim to RS, which wouldn't work. Now I say assign this alias, which has a better static type. Assign that to RS. This will work because you can see resident students as a static type can fulfill resident students. No problem. Right? This will work. Okay. So that's why this is going to work. So what we do is instead, you got RS over here. So now RS can indeed be pointing to just the same object over here after this variable assignment. And RS, don't forget, it has the static type resident students. So we really got 3 references in this context over here. You want to understand. Okay, recap. We got reference number 1, Jin. Reference number 2, the right-hand side, the alias we have created. And reference number 3, the new reference we're creating over here. You want to understand we got 3 here. And afterwards, you can definitely use RS dot, for example, premium rates. In which case, it's going to access maybe the premium rates in this object here. But if you say Jim dot premium rate, you cannot do it because Jim has a static type students, which would not allow you as part of its expectation. Be very clear about this example here, about expectation and also how you can somehow create an alias that has a different expectation. That's what we're doing here. And notice one thing, which is somehow we got to generalize. I'll talk about, okay, there will be some syntactic convention I can show to you. But before that, you can see here we say resident students, and then we can cast that to resident student. That's great. No problem. To think about more generally, if I have Jim over here, students, what would be the classes I can cast that into potentially? There will also be a range of classes I can do. That's something I will talk about. All right, just remember, you don't necessarily always have to put just a single class that corresponds to exactly the dynamic type. You don't have to. Right? That's why you will make it a little bit slightly more tricky, which we're going to talk about. Okay, before that, I will talk about some syntax to show to you. So when you talk about typecast, you can either give a name to the alias, or you can simply keep the typecast anonymous without a name. Okay, let's take a look at here. The name cast over here will be just, this one here will be just like what we said earlier. You have a phone over here, smartphone. And then you try to cast that into iPhone 13 Pro because you're pretty sure this object here has the dynamic type, this one here. You'll cast that to the same. And this will create an alias. And then you assign this new reference variable to point to the same objects as the alias, right? Exactly like what I visualized over here, right? And once you have done that, you can actually use this particular variable here of static type iOS to call FaceTime, which is part of the expectation, right? That's namecast. If you want, you don't really have to have a name for the cast. So this will be one example here. Okay, let's see. We got a phone, which is declared to be static type smartphone. Dynamic type is iPhone 13 Pro, which is valid. I can say now I know pretty sure a phone dynamically is an iPhone 13 Pro, right? Now I can try to cast that into iPhone 13 Pro right away. And then notice that you have to surround it by some extra parentheses over here. Once you have done that, you can say dot FaceTime. So what you should really notice is here. This part over here is an expression. This is an expression of static type iPhone 13 Pro. Okay, I'll write slightly better. iPhone 13 Pro. Because that's the type we're trying to cast that into. If you only say a phone dot FaceTime, it's not going to work. Because a phone is declared to be smartphone. Smartphone itself does not have FaceTime, as you can see. Smartphone itself does not have FaceTime. It only has the FaceTime down to iOS, right? So this is just another notation for you to see. Common error. How about this one here? Let's say you try to do typecasting, right? You thought, maybe I can delete these two parentheses. Maybe I could. No, you cannot. All right? So what's going to happen is, if you simply write this is important to remember. If you try to write this one here, the way the operator is going to work, think about this is more like a multiplication. This is more like an addition. You got to do multiplication first. The way compiler is going to execute it will be, this one is going to be executed first. However, is this one itself valid? Not really, because a phone declared to be a smartphone. Smartphone does not have FaceTime. All right? Not valid, because a phone's static type, which is smartphone, does not have the expectation. Does not expect FaceTime. Right, that's the rationale. Right, so this page over here will basically show to you, whenever you want to use typecast, you can either use the typecast notation and try to assign that to some variable and use it. Or, if you want to use anonymous cast, you want to make sure you surround it by parentheses. Just remember. If you forgot about surrounding that by parentheses, it will be as if you try to make the method call, followed by the typecast, but it's too late. All right. All right, any question? All right, question, go ahead. All right, this one here is simply even compile. It should not even compile. Yes, correct. Yeah, if you try this in Eclipse with this one here, it's not even going to compile, so you have no chance to execute it. Okay. All right, so let's talk about two things. Number one, to what class can I compile? Sorry, to what class can I cast into and still remain compilable? Number one. Number two, if the cast compiles, can I ever run into class cast exception? These are the two things we're going to talk about. All right. Before that, why don't we take a short break and take attendance, and then we'll start again. All right. All right, so before the break, we talked about the basics of typecasting. It's pretty much consistent with what you knew already before before even today's lecture. It's just about to know what's the motivation of doing casting, because compiler is simply cannot keep track of the dynamic type. That's something for your knowledge. And I want to do two things before I generalize the whole story. One, whenever you do typecasting, when does typecast compile? There will be some rule for you to follow, but that one still has to do with the expectation. All right, number one. Number two, if a cast compile, can it ever run into some runtime error, like an exception, right? So these are two things. All right, let's talk about one by one. And I'm gonna stay on my iPad page, and then everything is on the slide. I'll show to you at the end where you can look for them. Okay. It turns out when you want to do typecasting, there are two directions. You can either cast upwards or you can cast downwards. So what do I mean? Let's say, for example, I declare my phone over here to be of static type Android. And I'm going to put Android over here in the context. So this guy over here is a static type of my reference variable. All right, let's remember that. I can try to cast my phone into anything as long as either I'm trying to cast that into one of the ancestor, or I can try to cast that into one of the descendants. That's the rule. If you try to cast that into one of the ancestor, it's called upward casting. We're going upwards. And I want to ask you, intuitively, if I cast Android into smartphone for the alias I'm creating, does that alias have less or more expectation? Intuitively. Less, right? Because if you do upwards, you cast to smartphone, you're basically reducing expectation. Nothing wrong with it. On the other hand, if I say I want to cast Android over here down to any of the descendant classes, am I getting an alias with more or less expectation? More. All right. Now, intuitively, if I try to cast Android over here to be some class, for example, Huawei over here, compilation-wise, it's okay because I'm doing downward casting. I'm just adding more expectation to the alias. But what if the actual dynamic type at the runtime is actually Samsung? In that way, Samsung cannot really fulfill its expectation. So this is where I got runtime error. So I'm talking about two things over here. Number one, when does it compile? It compiles if you do either upward or downward casting. If it compiles, but if your dynamic type cannot really fulfill the expectation of the cast type, then class cast exception. That's a summary. All right, let's now do a little bit more detail. Okay, well, I just summarized what you should know, but let's now see the detail. So here, let's say, here we say with my phone, I cast that to smartphone, right? Smartphone is over here. So it's an upward casting. So the first one here, smartphone over here is a upward casting. Okay. So this is upward casting. On the other hand, it would be also valid if I try to do downward casting, for example, over here. And this will be Galaxy S21 Plus. Okay. So I can either cast Android into smartphone, which is okay. I can also cast that to any of the descendants, in this case, this. That's called downward casting. And what I want to go over with you is about what's going to happen after the casting. What's going to happen is, let's only talk about compilation, okay? I don't talk about anything at the runtime just yet. If I only talk about, let's say, my phone, at the moment, my phone has the static type Android. Right? My phone here. Okay? You can see my phone here. And then currently it has Android. What will be the expectation? It will be basically surf web, Skype, and dial. Right? We talk about expectation. So you can think about, so for my phone, it's going to cover dial, surf web, and also Skype. Right? The rest is not part of its expectation. So the middle here is about the variable without the cast, just Android. Let's see the consequence of doing upward casting, which you guys agree is going to be reducing the expectation. Let's see how. After this particular cast, right, we explained before the break how this cast is going to occur. And we're going to cast that into some smartphone, SP over here, of static type smartphone, which is over here. What will be its expectation for smartphone? Only dial and surf web. So it's going to be only dial and surf web, whereas the rest will just be not part of expectation. You can see what used to be part of the expectation, after the cast, we reduce it. Not anymore, because we do upward casting to smartphone. Right? What about downward casting? For downward casting, we basically casting my phone into Galaxy S21 Plus. That one there is basically here. All right. That one there is going to cover, let's see here. It's definitely going to cover these. And then it's also going to cover side sync. Also, it's going to cover, oh, that's it. All right. And what you can notice is, over here, let me do a summary. Without a cast, this is the expectation. After upward casting, the variable actually got reduced expectation. After downward casting, we actually got increased expectation. I'm only talking about compilation. Let's not worry about anything about class cast exception just yet. We will in a minute. All right, any question here? So this one tells you whenever you're deciding whether you can do a particular casting over here, since you talk about compilation, the only thing you want to ask yourself is, am I doing upward casting or am I doing downward casting? If you're doing either one of them, that's compilable. So given Android over here, I can cast that into itself, which is okay. I can cast that into smartphone, which is also fine. I can also cast that to any of the descendant classes that will also compile. But can I cast Android to iOS? No. It's neither ancestor nor descendants. So it's neither upward nor downward casting. All right? This is something I will also summarize either today or Tuesday. That's the first phase about compilation. Assuming that the typecast is compilable, can we run into runtime error? Indeed, we can. Let's see. Okay? We're going to do 1, 2, 3, 4. We can do 4 examples together. All right? It's going to be enough to give you enough intuition. All right? Talk about the first one. So we got Jim here, declared to be students. Jim is a student. And then dynamically, Jim is a non-resident student. Oh, let me draw a little bit better. And for the very first one, I'm going to do in detail with you. But for the subsequent ones, it will be easier to see. Okay, you can think about this student here is the static type of Jim. And the pink one here is the dynamic type of Jim. All right. Okay, good. And question here. In this simple example, you can see there's already something wrong. Jin is a non-resident student. Can we cast that into resident students? Compilation-wise, can we or can we not? It turns out we can, because as far as compilation is concerned, this is a downward casting. Because the static type for Jim is students, we can cast that into either student itself or to resident students or to non-resident students. Doesn't matter. As far as the compiler is concerned, it doesn't keep track of the dynamic type. So this cast over here is compilable. Compilable cast. More specifically, is a downward casting. Right, so far so good. And let me now draw the picture and show to you why this can be problematic. Okay? After executing up to this line, what we have is this. We had our initial Jin of type, static type students, which points to dynamically a resident students object here. Dynamic type. And then we are creating basically an alias of resident students. And then we are trying to give a name to the alias to RS, right? So that'll be the last one. So RS over here is also pointing to the same object. That's of type, static type, resident students. All right, so these are 3 references, right? We talked about this earlier. Jennifer, give me a moment. Let me finish this. Let's see. Yeah, you mean this one here, right? I agree. Thank you so much. I appreciate it. Thank you so much. Yeah, dynamic type here should be non-resident students. Good. That's what we have. But the problem is, at the runtime, RS is going to be used following the expectation of resident students. Is RS pointing to, right now, can really fulfill the expectation of resident students? Not really, because it's a non-resident students. All right, so that's a problem. So I'm gonna write to you about what's gonna happen here. So this expression specifically is going to throw some so-called class cast exception. And then let's now understand the detailed reason. Okay, class cast exception. Class cast exception can only occur given that the cast compiles. If the cast doesn't compile, you don't even need to talk about runtime. Okay, so now, several things. Number one, RS, which is over here, is expected to be used as its static type, which is resident students. That's point number one. All right. Number two, where RS is currently pointing to a non-resident student, as you can see the dynamic type. It is currently pointing to a non-resident students. And now the question is, can non-resident students at the runtime fulfill a resident students? You cannot. Because resident student, for example, might expect to use premium rates, which is not part of the expectation for non-resident. All right. Which cannot fulfill the expectation of resident students. Right? Both reasons are important. Right? So when over the weekend, when you try to catch up with the lecture for inheritance, I want you to try this. All right? In the interest of time, I got about 10 minutes. I will suggest this. Okay? One example here for you to see there's another class cast exception happening here. Okay? Maybe we can do one more, but before that, I'll let you do one more thing. Okay? One example here, another one, and another one. There are three more examples for you to see how the class cast exception can occur. I might just do one more. But before that, I want to do a summary. I'll take question first. Which one? So all three of them. All of them. The one I show? Yeah, that one will give you a class cast exception, yes. This one here. Yes, it will give. Especially over here, right? Because you're trying to cast Jim dynamically is non-resident students. But non-resident students cannot fulfill resident students' expectation. That's why. That's true. The static type student, so that's why it will compile. But we talk about two things. We talk about compilation. As far as compilation is concerned, you can either cast upwards or downwards. And here we're casting downwards, from students down to resident students. But at the runtime, if you allow the cast to happen, so that would mean you are going to allow this variable here to be used as resident students. But dynamically, it's actually a non-resident students. So it's not going to work. That's why class cast exception. So two things. So guys, I would suggest the following. I hope I will have a little bit more time to go over one more example, which I would really love to. But before that, let's now generalize what we have spoken about. And then this will give you some time to really reflect over the weekend. Let's say we'll talk about this hierarchy over here. So there are four categories of classes you have to remember. All right? Let's say we have this. I got my phone over here declared to be Android. So what I will do is Android over here is the static type of my phone. Dynamically, let's say it's Samsung. Dynamically. dynamically, it is Samsung. Okay, I'm not going to talk about compilation time and then runtime. Compilation time. What does it really mean for a typecast to be compilable? If I ever want to cast my phone into another class, what can I do to make it compilable? Upward or downwards, right? So first one will be compilable cast. I can either go upwards or itself, or I can go downwards. So all these classes, if I want to cast my phone into it, it will be okay. No compilation error on Eclipse. Okay, number one. Number two, what does it really mean when it doesn't compile? That means you're trying to cast my phone into something that's neither ancestor nor descendants of Android, right? So for that one there, I'm going to use orange. So in this case, obvious, iOS over here. So these are neither ancestor nor descendants, okay? We're going to subdivide. Out of all these classes that we can cast into, either upward or downward, that will compile, some of them are going to give you class cast exception. So now let's visualize what's happening here. Now we talk, whenever you want to talk about class cast exception, by the way, let me just clarify one more thing. This one here, and these one are about compilation time. Whereas these two are about runtime. Right? It's different. If we're only talking about compilation time, you only look at the static type, right? But now, if I want to talk about runtime possibility of exception, I need to look at the dynamic type as well. And the principle is very easy. If I cast Android into a class that cannot be fulfilled by its dynamic type Samsung, then it should be class cast exception. Ask yourself this. Can Samsung fulfill smartphone? Yes. Can Samsung fulfill Android? Yes. Can Samsung fulfill itself? Yes. Can Samsung fulfill Galaxy S21 Plus? No, it's a descendant. What does that mean? If you try to cast your variable into a class that's not an ancestor of your dynamic type, you run into class cast exception. That's a rule you will see on the slides. All right? All right, so now exception free will be this one here. This one here is also exception free. This one here is also exception free. Okay? The blue ones are exception free because the dynamic type Samsung can fulfill its expectation. On the other hand, the other ones that will compile, I'm gonna do, let's see, what's the color really? Okay, I'll choose the closest one. How about this one here? Okay, this one here, and this one over here, and also this one here, and this one over here. So all these are, I'll write it down. All these are compilable, but it's going to give you class cast exception. All right, let's now write it down. So for the blue one over here, 1, 2, and 3 can be fulfilled by the dynamic type, which is Samsung. On the other hand, for all the others, let's say 1 here, 2, 3, 4, and also 5, right? All these 5 classes cannot be fulfilled. By the dynamic type. Right? This page really summarizes everything you need to know about cast. It talks about compilation time, also talks about runtime. And I would expect you to know this very well when you go to that December 8th exam. All right? Am I right? December 8th, right? Yeah, good. All right, take some time. And then if you want to ask me questions, maybe next time in the recap, feel free. I do expect you to struggle a little bit about this, but I try to talk about that first. Okay, how about I'll do one more example, and I'll let you go. Just one more. All right, given this context over here, let's now talk about different example, right? Let's talk about, how about this one here? Just this one, and that'll be it. As you can see, we have some we have some cast expression here. Number one, does it compile? What you gotta do is look at the static type. We got smartphone over here for a phone. And then we are now trying to cast that into iPhone 13 Pro. Is this compilable? Yeah. Downward or upward? Downward. All right. Compiles because downward. All right. Now let's talk about runtime because it compiles. If it doesn't compile, don't even talk about runtime. It compiles, let's talk about runtime. So if you don't want to talk about runtime, you have to look at dynamic type. Dynamic type is Galaxy S21 Plus, which is over here. Now, for you to determine whether there should be a class cast exception, ask the following question. Can the dynamic type of this variable here fulfill the type that you want to cast into? Can it or can it not? No. Class cast exception, right? It's not too bad. I'm going to write it down, okay? Class cast exception. Because dynamic type, which is Galaxy S21 Plus, cannot fulfill the expectation of the cast type, which is iPhone 13 Pro. All right, so that's the reasoning you want to also review. All right, any question? Go ahead. Actually, in this case, if you try to do any, okay, let me see. What would be the class cast exception possibility, right? If you give me 20 seconds, I promise, okay? If you try to cast this one here into iOS, that's okay, because this can okay. If you try to cast this one into over here, that's okay, because Galaxy S21 Plus can fulfill any of its descendants, okay? But if you cast that into, for example, here, or here, so these are the class cast exception classes, right? Okay. Yeah, think about it. So for this one here, you can try to link to this diagram that we try to draw. All right, guys, review it, and then we'll do more exercise on Tuesday. Okay? Be well.